Hello everyone, today in this video we'll be discussing the fifth module of CN, which is related to application layer. And in this topic we have 8 subtopics present. We'll be discussing each of them, which is important from the exam point of view, and what do you remember in each of them. So before starting, make sure you hit the like button and subscribe to my channel. That helps me make more videos like this. Without wasting more time, let's get started. The first one is introduction to application layer. Okay, so application layer, as you know, it is in the top of all the layers. We have the TCP/IP model, right? So in that, the top layer is the one which is application layer, and the user directly interacts with the application layer. Okay, so what are the protocols present in that? That we'll be discussing. Okay, so application layer is the topmost layer. It is easier to add and remove protocols from this layer. Okay, so we can add and remove protocols based on our own requirement. Okay, we'll be defining some protocol if it is required, and we'll be adding it to the application layer. Okay, and there are standard and non-standard protocols. Two types are there, and two paradigms have been developed: client server and peer to peer. By using these two paradigms, either of them will be making use of application protocol. Let's understand what is the difference between client server and peer to peer. So this is the basic diagram of client server. Very easy to understand here. See, the clients are present here, which are the computers. Our computers are present, and this is the server where all the data will be present. And whenever a client requires some data, the client will be requesting to the server, and the response will be sent back from the server, so that the transaction will be completed. Like that, we will be accessing the data from the server. This is in this way it is called as client server. Next is peer to peer. In peer to peer, there is no single server. Here both client and server are the computer itself. So the computer will be having some data and it wants some data. So suppose that this computer has some data A. Okay, and this has some data B, this has a data C. Now this computer requires data B, so it will be requesting from this computer. Okay, and this computer requires data C, it will be requesting from this computer. This computer requires data B, I mean data A, so it will be requesting from this computer. Like that, they will be requesting from each other, and the sending and receiving will not be at the same time. It will be one after the other. Okay, simultaneously it will not happen here. Okay, but simultaneously it will happen here. The sending requesting and the response will be sent to the client. Okay, different client will be sent, but at the same time it will happen here. One time one thing will happen. Okay, so that's the difference between the client server and peer to peer. Let's discuss the client server in detail. Okay, so to access the server, see, I told you, right, this is the server and this is the client. If client gets all the access to the server, it can make misuse of it, right? So we should restrict the client to what data it wants, right? Suppose client requires data A, we should not send the client inside the server to search for data A. In that way, we are exposing all the data which is present, which is confidential data also will be exposed. So for that, we'll be defining a interface in between, which is called as API. API is like a door, okay, and a security guard is standing here. So we'll be telling the security guard, I want the particular information. Security guard will go inside and take the information, come back and give to the client. That role is played by API, application programming interface. Okay, so the connection is formed using sockets. We cannot directly form a connection, we have to use sockets in between. So sockets are the ones which will handle the connection stuffs, and the client and the server will be dealing with the sockets. Okay, so request will be sent, and the socket will be forming a logical connection to the server, and the request will be sent back here, response will be taken from here, and it will be sent back to the client via the logical connection. So sockets also have address. In the following diagram, it shows the address: 32 bits for the IP address and 16 bits for the port number. So for one address, there can be many ports through which we can access the server. Okay, so through which port you are going to access the server, that also is required. That information will be present in the second half of socket address. There are two types of socket address: local and remote. Local is the socket address which is given by the system, and remote is the one which is given to the logical connection. When we form a logical connection, a fake address will be given to the logical connection, and that will be mapped to the original address. Okay, that is called as a remote address. These sockets interact with the transport layer protocols. In the TCP layer, right, it will be interacting. The sockets is interacting with which layer? TCP layer. Okay, and also it interacts with the UDP also. Okay, transport layer includes two protocols, UDP and TCP. Both of them it interacts. Okay, during the interaction, there are sockets defined for listening and exchanging data. There are two types of sockets. Okay, one is for listening, means only establishing connection. This is the one which is the listening socket. What it does, it will only establish the connection. Okay, its job is to only establish the connection. And another socket is there which exchanges the data. This is the socket which exchanges the data, this one and this one, and this one just establishes the connection. Okay, and here is the client, here is the server. The data gets transferred from the server to the client. Okay, next is www or World Wide Web and HTTP. Okay, what is www? It consists of web pages. So you can imagine www as an big space here, and inside the big space there are many web pages present. Okay, and what are these web pages have? Web pages have some information or content. Now these web pages can be accessed via hypertext or link. I want to access one web page, so that web page will be having a particular URL. Okay, that is URL is called as hyperlink or text, hypertext. Okay, hypertext has been upgraded to include hypermedia. If it only has the text information, it is called hypertext. If it has the audio video information, it is called as hypermedia. Okay, and www uses client server architecture. Each site holds one or more web pages. Okay, in each site you can have multiple pages, so similar web pages will be forming one particular site. Okay, so the client can request to multiple sites. Okay, and the information will be fetched from there. What is a browser? Browser are used to handle protocols, interpret web pages and display it on the screen. So directly the data which is present in the web page, that is not human readable format, it will be in the binary format, right? So to interpret this one and display it in human readable format, we use browser will do that task. Okay, and it also handles the protocols. Like the browsers include Microsoft Edge, Google, Firefox, Netscape, etc. To identify a file in a web page, now web page has a lot of content. Inside that the files can be present. It can be a video file, audio file, text file, or it can be a GIF, it can be a PDF, or it can be any image also, right? So all those things are called as files. So to locate that file, URL is used, Uniform Resource Locator. That link will specify a particular file itself. Okay, not the general link. It will give us the path to that particular file. Okay, like .pdf it will be at the end, .html it will be at the end, .mp3 will be at the end of the website. Okay, that is URL, Uniform Resource Locator. Now there are four parts in URL. Okay, so the four parts are: first is protocol, which protocol you're using, HTTPS or you're using HTTP or SSH or some other protocol you are using, that will be specified here. Here the host and the port will be specified. Host means Google, right? Google.com, or it can be Firefox.com. Those are the hosts present, and the port will also be specified in case of local access, like port number 80 for we'll be using port number 80 for HTTP, right? So here port number 80 will be specified if you are using port 80, but this will not be specified. It will be taken from default when we are accessing the internet. Okay, and path will be here like slash this page slash this page slash this content, like that. Okay, so the whole path will also be given. So there are four parts in the URL format. Okay, www web documents can be categorized into three basic categories: static web documents which have fixed content, dynamic web documents which will be having a script, and that will be run and the content is generated. So in dynamic web, what happens is, based on our input, some input will provide, and that based on that input the data should be shown. So a script will run to fetch that data and show that. Okay, that is called as dynamic web page. Active web page is what script itself is passed, like an animation movie. If you want to display a movie in a website, we will be passing that script of the animation itself, right? So that animation will play. That is called active website. Okay, no program is running there, we are passing the program to run the movie. Okay, what is HTTP? Hypertext Transfer Protocol. This is also a protocol. It uses the 80 port in the server side, and the client side it is random. Okay, and it works with the TCP protocol. Okay, and there are two types of connection: non-persistent and persistent. What do you mean by non-persistent? Connection is made before each request and ended after it. For one transfer, you'll make a request and then you'll end it. That is non-persistent. Persistent is the connection is made and kept until either the timeout happens, or manually it is ended, or data length reaches the limit. How much data is to be transferred? If there is a limit set, if that limit is reached, it will break the connection. Until then, any much data can be transferred in between. Okay, that is persistent. So this is the format. Here we have four things: request line, header line, blank line, and body. Okay, so in the request side, here this line will be of the request. It will specify the method space URL space version and CR if. Okay, and here will be header name, and here will be CRF, it's a blank line. Here it will be having the body, and response will be having one different is changes, which is having a status line here. Let's discuss what are the different methods and header names present. So moving on to the methods and the header names. Okay, so methods include get method. You are getting the data or posting it or putting it or deleting, or you're using some options. So that methods will be specified during the request as well as in the response, which thing you are getting the response for. Header names for request and response, they are different. For a request, it includes user agent, accept, host, date, upgrade, cookie, etc. while requesting the message. These data is to be transferred along with that. And in the response, we get date, upgrade, server, set cookie, content type, and location, etc. Okay, these are the header names included. Cookies are used to store the client's data when he or she visits a website. Okay, so if I visit a website, I see some cloth brand. Okay, and that particular cloth brand I see a lot. That means I'm interested in that brand. This information is stored inside the system. That is called as a cookie. Okay, cookie will store that information, and next time when I visit that website, based on that cookie which I had been given, it will show me that specific brand's websites only. I mean the brand's clothes only. That is what cookies are used for. An e-commerce website uses cookie to store the items added to the cart. If I add a cart, like in the cart, there will be, right, in the Amazon and all, there will be cart, and inside that cart, if I add whatever the item I want and I go back and come back again, that cart will be present here until I delete the cookies, right? So this is what the cookies are used, where we can continue shopping even after we go back and come. Okay, this is applicable for registered users. A web portal also uses cookies in a similar way. Web portal for showing you the information which you are interested in. Cookie is also used by advertising agencies to promote their product to the people who are interested in that. Okay. Next is the file transfer protocol. Here the protocol is defined for transferring the files. Okay, and it uses TCP and transfers the files from one host to the another host. This is the diagram, very simple. Here you have the local file system, and here you have the remote file system. You can access from the local system or you can access from the remote system. And here is the client, here is the server. Okay, and client, it has a user interface and a control process and data transfer process. It interacts with the local file system. Okay, and the data which is fetched from the server, that will be stored here in the local system. If it wants some other data, it will make a request to the server will fetch it from the remote file system, and then it will send back to the server, and from there it will send to the client. Two connections are there: control connection, which defines connection made between them, the information related to that, and the actual data which is getting transferred, that will be sent here. Request response will be in the data connection. Okay, so control connection which is present during entire interactive session. Okay, once established, till the entire session is over, it will not be broken. But data connection is started and ended after each file transfer. One file is transferred, connection has to be made for next file transfer. It uses port 20. Okay, and data connection requires three attributes of communication: the file type, like ASCII or EBCDIC file, or an image file, which file type you are going to transfer. Data structure means the file and the pages in what way it is organized, and the transmission mode. Stream means continuous transfer of the data. Block means in blocks it will be transferred. Compressed mode means it will be moved to a zip file, and then the compressed data will be transferred. Okay, so which thing we are using, that has to be specified in the data connection. Okay, for security, SSL is used, which is secure socket layer. Okay, next is email. Email, we all know what it is. Here agents are used. Okay, for sending and receiving the data. Two types of agents are there. One is the user agent, second is the mail agent. And mail agent is divided into two parts: mail transfer agent, mail access agent. Transfer is done at the sender side, and access agent is used at the receiver side. Now UA is the user agent, which is the client. They send a mail to the MTA client. MTA client sends to the MTA server, that will be forwarded to a stack and MTA client here. And the MTA client connects with the MTA server and transfers via internet. And here it will be fetched and it will be taken to MAA server. This is the mail access agent server, and that will transfer it to the MAA client, and that will be sent to the receiver side, UA, user agent. Okay. So email address uses the following format. Here it will be the local part, the mailbox address of the recipient. Here we'll be having our own email address, and at the rate, which domain you are using. Is it Yahoo? Is it Google? Is it Hotmail? Is it Outlook? Whatever it is. Okay. So that will be specified here. Okay. And mail uses which protocol? SMTP, Simple Mail Transfer Protocol. In three phases, email gets transferred. How many phases? Three phases. First is connection establishment, message transfer, connection termination. Very simple. establish, transfer, terminate. Okay, and mail agent uses POP and IMAP. POP is the post office protocol, IMAP is the internet mail access protocol. Okay, let's have a look at each of these. The post office protocol will be having as such, here will be having the POP server, and here will be having the client. Messages are pulled from the client, username is sent, password is sent, so that authentication is done. After that, the data is sent here and it will be retrieved from here. Okay, so the transfer will happen, it is authenticated. Okay, and POP3, there are two modes are there, delete and keep. Okay, in delete mode, mail is deleted from the mailbox after each retrieval. In keep mode, mail is kept. That's the difference. Two modes are there, delete and keep. This is to store the old mails, and this is to, this is not to store the old mails, and this is to store the old mails. Okay. Next is IMAP 4, which is Internet Mail Access Protocol version 4. It is used for the same purpose, but it is more powerful than POP3. Why it is more powerful? Because we have some extra features here. Which are the extra features? A user can check email header prior to downloading. Checking email header is not provided in the POP3. User can search the content of email, partially download the email, create, rename, and delete the mailboxes. These features are not given to the POP. Okay, that's why IMAP is more powerful. We have MIME, which is multi-purpose internet mail extensions. Here for the normal data we use the IMAP, POP, SMTP, but for non ASCII data, okay, that kind will be using the mail multi-purpose internet mail extension, MIME. Okay, it is a supplementary protocol that allows non-ASCII data to be sent through the email. So here is the user agent and MIME is presented, it will send to the MIME. Email system will forward to the server's MIME, and that will be received by the receiver at the server side UA. Okay, user agent. Here three things are there. Content type, which content type you are going to send. Is it text, is it multi-part, or it's image, video, or audio? The transfer encoding used 7-bit, 8-bit binary base 64. Email can be sent by a mixture of protocols like SMTP plus HTTP, SMTP at the client side, HTTP at the receiver side, or both will have both of them present, or you can use the other protocols also present, FTP along with HTTP and so on. Okay, so all the combinations also can be possible, okay, whenever it is required. Next topic is telnet, which is the short form for terminal network. Now it is related to remote logging. If I have a computer in USA and I want to access this from India, we'll be using the telnet to make a connection to that computer. Okay, so here it is used for accessing remote systems by internet. Here we'll be using the interface, which is network virtual terminal. NVT is used as an interface to send and receive data. There should be an interface through which we'll be sending the data. If there is no interface, you cannot send the data. That interface is network virtual terminal, NVT. Okay, and server telnet transfers the data and commands from the NVT form into the form acceptable to remote computer. Okay, so we have a local system here which will be having some data and the commands, and that will be transferred to the server or the remote desktop in this case through NVT. NVT will be transferring the data from the client to the remote system. Okay, so here's the client, telnet is present, through NVT it will transfer to the server slash remote desktop. Okay, the last topic is SSH, which is secure shell. Okay, why is SSH needed? Because security is important, otherwise hackers will hack all of your data, right? SSH is an application protocol to make the transfer more secure. Okay, application layer is here, TCP is here. In between them, SSH is provided for TCP. Whatever data is present here, it is to be made secure. SSH is put on that. There are three things here, which is SSH connection, SSH authentication, and SSH transfer. Okay, so here we'll be having the first SSH trans. So since TCP is not secure, SSH provides a top layer of security. Means on top of TCP there is a SSH layer to make it more secure. So the following services are provided by SSH trans: privacy, data integrity, whatever data we are going to send, that should not be conflicting. The server authentication is done before sending the data. Compression of message is done to send the data faster. Second is SSH auth. Both client and server are authenticated for each other in this layer before sending the data. Both should be authenticated. SSH connection, it provides multiplexing. Okay, what are the applications of SSH? Used for remote logging, used for the file transfer, and port forwarding also. What does port forwarding mean? Creates a tunnel to transfer other protocol data. If there are different protocols at the server and the receiver and want to transfer this data, what does SSH do? It will create a tunnel. Through the tunnel you can transfer any protocol data. Okay, that's what SSH does in port forwarding. The packet format for SSH is length, padding, type, data and CRC. Okay, and the length is also given here for each of these. Okay, main data is sent here. The last topic here is the DNS, which is domain name system. It is used to map the name with the address in the internet. Okay, map the name with the address in the internet. See, addresses will be some random numbers here. Okay, we cannot remember numbers, we can remember the letters. So this is mapped to a letter. This another address is mapped to another letter. Another address is mapped to another letter. This mapping is done by DNS, domain name system. So here user is present and it wants to access the address. What it does, it has the host name. Like for example, we have a website ABC. We want the actual address which is present inside the internet, so that using the numbers only you can access inside the internet. By using ABC we cannot access. Okay, because numbers is the where address is stored. Okay, so we will transfer the host name to the file transfer client. It will send to DNS client. It will query to the DNS server, which will check what is ABC related to. ABC is equating with 123. Okay, so 123 is the address. That response will be sent to the client, which will be sent to the file transfer, and that is called as IP address. Host name and the IP address are mapped with each other inside the DNS server. Okay, and namespace and domain namespace maps the names to the addresses. This also handles conflicts in the same names. If there are more than one host name with similar name, you will be having to resolve that conflict which you are referring to. So some slight differences will be made. Okay, so there are methods for handling the conflicts which will be used by DNS. A full domain name is separated by dots. Okay, like 127.0.0.1, right? So this is a subcategory of 127. And 0, and this is a subcategory of 127.0. This is a subcategory of 127.0.0. Okay, like that. Labels can be used at each level. Okay, for example, this is my URL a computer.b department.topuniversity.edu. So here what happens, edu is present at the top layer of that top university, at the top layer of that b dept, or the top of that a computer. Okay, so this is the hierarchy present here. This is the root node which has all the data, and that will be subdivided into different categories, like it is .com or it is .edu, and based on that different domains are formed. This .edu, all the ones which are ending with .edu will be here, all the ones which are ending with com will be here. Based on that, inside these different websites will be there, their own sites, and all sites will also have some subcategories present. So based on that, there will be different subdomains as well. Okay, and all the nodes cannot be stored under a single server. If there is a single server, all the nodes which are present can't be stored in the same one, right? So there are different servers. So each server will be having some few nodes. This server will have this nodes, this server will have this nodes, and so on. So the servers which have those nodes, those are called zones. Okay, this is zone 1, this is zone 2, this is zone 3. In each zone there is a server assigned to that. Okay, there are two types of server: primary server, which stores the file about the zone, the data of zone. Okay, not detailed data, normal data, basic data. And secondary server has the detailed data, and it also transfers the data from one zone to other zone. Okay, and there are different types of domains: generic and country domains. Generic domains end with .info, .edu, .org, .gov, .coop, etc. Country domains .ca, .us, and so on. Resolution refers to the mapping of name address. Okay, if name is given, which address it is assigned to, that has to be mapped, right? There is a recursive and iterative resolution. Recursive means it will resolve until it reaches the end, like name address, that address if it has a sub address, and so on. Iterative means one by one, first all names will be resolved, then the addresses, then sub addresses, and so on. Okay, DNS has two types of messages: query message and response message. In query and response, this is the same format used. Here we'll be having identification data, flags, number of questions, number of answers, number of authoritative records, number of additional records, question and answer section, authoritative and additional section. All these data are present, which is used in mapping the name to the address. Okay, DNS has this. Registrar is a thing which enters the new domain names in the DNS database. If a new domain comes, who will be entering that new address inside the database? Registrar will be entering that. Okay, and in DNS, when there is a change like adding or removing a host, okay, suppose that one host is removed, I don't want a host to be staying in the DNS, I'll be removing it, so address will be empty there, and that address has to be utilized. So all the previous address that has to be changed to accommodate this space, right? So that changes are manual. Okay, manual, and it takes a lot of time. To automate that, we'll be using DDNS, Dynamic Domain Name System. Whenever adding or removing of the host is done, the address changes which happen, that will be automatically handled by the DDNS. Okay, and to provide security to DNS, we'll be using DNS SEC, which is providing a message origin authentication and message integrity using security service called a digital signature. This will ensure that DNS mapping is secure. Okay, that's all. If you found this video helpful, please do like and subscribe. It helps me make more videos like this. Thank you so much for watching, and I'll see you in the next one.